Tuesday, November 24th. We're about to roll into our little Thanksgiving break here. So before we hop into this geometry video on lesson 4.2, I just want to remind you guys to take a minute, be grateful, think about what you have in your life, be thankful for it, especially, in the world we're living in now. Not everybody has everything on easy mode, so, things may be tough for you, but it's probably could be a lot worse. So just try to take some, some pride in that you have something good to hang on to in your life. And worst case, I'm here and I'm grateful for you guys. So let's get it going. Today we're going to be talking about lesson 4.2, Transversals and Parallel Lines. Alright, so we're going to look at the lesson here. So, we're talking about transversals and parallel lines, and the essential question, the big idea today, is how can you prove and use theorems about angles formed by transversals that intersect parallel lines? Well, we got to know what all that stuff is, and I don't know what that is, so let's do it together. And we'll come back and answer that question. So a transversal is a line that intersects two coplanar lines at different points, two different points. So in the figure T, there you go. T is a transversal because it intersects these two lines at two different points. So we have the name of the angle pairs, so there's going to be a whole lot of angle pairs, right? Because there's a whole lot of intersections, which means that we have a bunch of different intersections. So we have a bunch of vocab. You're going to want to get this down. You're going to want to jot notes of this. You're going to want to put this diagram into your notebook. We have corresponding angles. They lie on the same side of the transversal and on the same sides of the intersected line. So the example would be angle 1 and angle 5. Those are corresponding angles. We talk about same side interior angles, and they lie on the same side of the transversal and in between the intersected lines. Again, so this one, you can see this is going to get a little tricky to recognize all these. So 3 and 6, notice how they're kind of in the same box. We got alternate interior angles, so they're non-adjacent. They lie on opposite sides of the transversal. Find a different color between the intersected lines. So we have 3 and 5. So angle 3 and angle 5, and that's for that alternate. So alternate interior, same side interior, and then you have alternate exterior. So it starts becoming can we match these things up? So 1 and 7, they lie on opposite sides of the transversal and outside. So 1 and 7. So those are giving me like vertical angle vibes, even though they're not. But that's 4 different types of angle pairs that you need to be highly aware of. So I'd put that in your notebook. I'd get that as a strong note for yourself. Alright, so parallel lines in the same plane, they never intersect. They never touch. You could be very, very close to your soulmate and you're just never going to ever see them. Sorry, parallel. Make sure you remember that. So when parallel lines are cut by a transversal, the angle pairs are either going to be congruent or supplementary. So what does congruent mean? The same, right? Supplementary, do you remember? It adds up to 180 degrees. The following postulate is the starting point. So we're going to want this. This goes into your notes. Same side interior angles postulate. Boom, boom, boom. Lots of words, lots of vocab. It can get tricky, so you're going to want to make sure you have very nice and organized notes on this one. If 2 parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. So first, let's go back up. What's a same side interior angle? They lie on the same side of the transversal in between the intersected lines. So when you do this, let's find the pairs. So I can look and see that there's my transversal, there's my parallel line, so 4 and 5, that's an angle pair, same side interior angle, and 3 and 6 as well. What does the postulate tell you about these same side interior angle pairs? Well, how you would write this out, and this is where we start getting into some formal-ish language. So given P parallel to Q, then angle 4 and angle 5 are sup, and you can say the same thing about 3 and 6. Supplementary, you can clearly see that P is a straight line, 180 degrees, because it's following the postulate. So make sure you got that. So as an example, if the angle measure of 4 is 70 degrees, what would the angle measure of 5 be? And make sure you can explain it. So obviously they add up to 180, right? So this would have to be 180, 110 degrees. You know that they're supplementary, so you would say the measure of angle 4 plus the measure of angle 5 equals 180 degrees. Bam. And then you'll continue and you could write out that 70 degrees plus the measure of angle 5 equals 180 degrees. So long story short, right, the angle measure equals 110 for angle 5. How can you find measure of angle 3 if P is parallel to Q and measure of 6 equals 61? Well, 3 and 6 follow the same rules, right? So 3 and 6 are supplementary, which means they add up to 180 degrees, right? So if it's the measure of angle 3 plus 61 equals 180, simple math, right? Basic one-step equation, the measure of angle 3 would equal 119 degrees. Algebra. Rocking with the algebra. Some things to consider, when two lines are cut by a transversal, how many pairs of corresponding angles are formed? The answer would be cuatro. And how many pairs of same side interior angles? The answer would be 2. What does the same side interior angles postulate tell you about the measure of a pair of same side interior angles? We've been talking about this all day. 180 degrees. Supplementary, 180 degrees. So what if M is parallel to N? How many sides of same side interior angles are shown in the figure? What are the pairs? Well, there's 2 pairs. Got 2 pairs. Get the stomping. She'll know about some Air Force ones. So we got 3 and 5. And we got 4 and 6. Bam, bam. Let's keep it rolling. Alright, explain 1. So we're going to take a look here and prove that alternate interior angles are congruent. So you're looking at same side, now we're looking alternate. Think about what that means for you. Here is the theorem. You're going to want to get this down. If 2 parallel lines are cut by a transversals, think of that like your knife cutting a nice Thanksgiving pie. Personally, probably making, well, I am making sweet potato pie, pumpkin pie. The pairs of alternate interior angles have the same measure. Vegan too. So to prove something to be true, use definitions, properties, postulates, theorems, etc. You show your work. That's why I've been asking you guys to explain and justify more often, because you gotta be able to do that. That's life, right? What's your given, what's your proven. So you're given that P is parallel to Q, and you need to prove this. So until you do that, and you have evidence to back that up, you are not done with this task. Alright, so these is a 2-column proof. I don't love these, I'll be honest. They're rigid, but what they are is sometimes they give you the fill in the blank. So you're given all these, and you can use them more than once, and you need to fill in. And what is that? So obviously, we know already that this is given, hopefully. So how do we get there? Well, 3 and 6, angles 3 and 6 are supplementary. That is the same side int angles postulate. So I should have numbered these. That'd be easier than you writing this out. So that's what we'll do from here on. 1, 2, 3, 4, 5, 6. So I don't have to just write a bunch. Number 3, that is going to be the definition of supplementary angles, because the measure of 3 and the measure of 6 equals 180. That's, you say it is supplementary, and then what does that actually mean? Angles 5 and 6 are a linear pair, and that's given. So that's number 2. That's a given, and you can look at that right there. 5 and 6 supplementary. That is the linear pair theorem. Think back to 4.1, and that's number 6. Measures 5 and 6 equal 180. That's, again, the same thing that we put in number 3. It's the definition of supplementary angles. Okay, we got a little more math here. So the measures of 3 and 6 are equal to the measures of 5 and 6. Well, they're both supplementary. They're both 180. We know that. And you can prove that using the SPE. Sorry, I call that, that's not the SPE. 4 is SPE for me. Substitution property of equality. You drop that in there because you can plug in the numbers and you'll see. And then for 8, you can just do the math. You subtract the measures and you'll end up with the subtraction property of equality being the reason that you get down there. So it's taking what you're given and it's using it as justification. It's saying this happens, this happens, this happens. You need to tell me why. Why do angles 1, 3, 5, and 7 all have the same measure? So let's mark those. 1, 3, 5, and 7. Why do those all have the same measure? Well, we can say that 1 and 3 and 5 and 7 are equal because of the vertical angles theorem. Right? That's what we learned in 4.1. Vertical angles, and then 3 and 5 are alternate interior angles theorem. So we have the alt interior angles theorem. And then we have our friend the transitive. Well, my handwriting sucks today, I'm sorry. Property of equality, and you can say that, you know, that 1 equals 3 and 3 equals 5 and 5 equals 7. So they all equal to each other for those reasons. Alright, hopefully you're with me. If you need to go back, jot some stuff down, do it. Take your time. There's no rush here. Explain 2. Proving that corresponding angles are congruent. 2 parallel lines cut by a transversal also form angle pairs called corresponding angles. So there's another theorem, corresponding angles theorem. We're just learning all the theorems. And again, this can take a lot to get in your brain, so take the time to do it. If 2 parallel lines are cut by that transversal, the pairs of corresponding angles have the same measure. So pairs of corresponding angles have the same measure. That's what you need to take out of that. Alright. We're given a diagram. Same diagram we're working with. We're given some info and we need to prove this. That measure 4 is equivalent to measure 8. So, by the given statement, 4 and 6, so 4 and 6 are, they're not on the same side, so they're alternate interior, let's try and write a little better, angles. So knowing that, we can use the alternate interior angles theorem, which suggests that those are the equal measure. So the measure of angle 4 is equal to the measure of angle 6. So this is like pulling out your toolbox. I can do this. 6 and 8. So 6 and 8 form a pair of vertical angles. So using the vertical angles theorem, what does that tell you? That they are the same measure. So using the substitution property of equality, because we're going to plug in substitution prop, if you put 4 in for 6, you can substitute the measure in. And then you'll end up with the statement that says, because you can replace, I'll mark that, you replace 4 with 6, you'll end up with measure of 4 equals measure of angle 8. Because they're equal. So identify what angles you have, identify what angles you need, and then use those theorems to prove your point. Basically here, guys, you're just using the same side interior angles theorem for measure 4 and measure 5 to suggest that they're supplementary. And then you can also say that a linear pair for, and I'm giving you guys this so you can go take a look and verify it. 4 and 1 is equal to 180, and then therefore you can say, you know, this is where you substitute, or actually you would subtract out the 4, and you get measure 1 is equal to measure 5. Alright, so here's like an actual application of this where you need to plug in the numbers. So measure of angle 4 equals, or 36 degrees, find measure angle 5. Well, we can say that it would have to be 144 because measure 4 and measure 5 are same side interior angles. Right? Is that what I want to say? Yeah, they form a linear pair, right? So they'd have to be supplementary. Well, and then if you look at this, so we have this. I said that wrong. So forget what I said. Measure 1 and measure 4 are a linear pair. So those are supplementary, right? So measure 1 plus measure 4 equals 180 degrees. All right, and we're looking for measure 5, right? Yeah. Okay, let's go see what else we got. So we know that the angle measure of 1 has to be 144 degrees. Because angle measure of 4 is 36 degrees, you add that up, you get 180. Now, because, and I need to erase some of this because this is messy. Let's clean this up just a bit, and that's why you're going to want to just sketch new diagrams every time. What it will do, so 1 and 4 make 180 degrees, right? That's a linear pair. We're looking for measure 5. We know that measure 4 is 36 degrees. Okay? So corresponding angles theorem, you know that 1 is equal to 5. Yep, so I was definitely talking crazy earlier. So because this is 144, this also has to be 144. Big brain, big brain. All right, let's keep it moving. This is a lot of words in this one. A lot of words, a lot of notes. So, explain 3. Using parallel lines to find angle pair relationships. I'm not going to do you the disservice of reading this for you, so please read through it. Try to make understandings. Notice where these things are and where they exist. Okay? So we'll do the letter B together, though. So A and B are parallel. We need to find this measure. So where is that? The measure of W, UV. Okay? That's what we need to find. So, it is given that the measure of PRS, so PRS is 9x. And WUV, which I marked in red, is 22x plus 25. So, if we look at MPRS and MRUW, where's RUW? R, there's R, there's U, there's W. They are equal because of the corresponding angles theorem. Corresponding. And what does that mean? They're corresponding angles. So RUW and WUV, which is in red, I'm trying to keep my colors somewhat accurate, are supplementary angles, right? So we're looking, let's use green. We're looking here. That makes a linear pair, right? It'll be 180 degrees. So because of that, we can say that RUW plus WUV is 180 degrees. So if we solve for x, we add it up, right? So RUW is the same as this one, right? PRS. So that means it's not, they kind of skipped a step. It's 9x plus 22x plus 25, right? That's this angle plus this angle, and that's equal to 180, which is how they got this, just in case you got lost. Where they go from there then is they solve it, and you'll get x equals 5. So subtract 25, divide by 31. And then you plug in the x back in to find the value. So if you plug it in here, you get 22 times 5, which is 110 plus 25, 135. 135. So you plug it back in, you get the WUV. So you see here, guys, once you know the relationships, you can manipulate the information that you have to set up equations to solve for what you need. So hopefully that's not going to go over your head. What I'll do for your turn here is I'm going to just jot down some answers for you. So do this on your own and then check these answers. I can tell you you're going to want to use corresponding, you're going to use alternate interior, solve the equations. But again, please pause and do this on your own before you even jump in. We're rolling. So, is there anything here that we need to know? So if you know that P and Q are parallel and you're given one angle measure, can you find the other ones? The answer is yes. Yay. Like for example, if you had angles 1, 2, 3, 4, if you knew one of them, you can use the fact that you have supplementary linear pairs and vertical angle theorem to get all those, and then you can use the other theorems that we have, the alternate interior, the corresponding angles, to find one of these, and then you can just continue from there with the linear pair theorem, vertical angle. So it's pretty cool, pretty powerful. So to sum it up, let's go, basically guys, we're talking about transversals, parallel lines, finding congruent angles that are corresponding, finding the alternate interior angles, finding the supplementary angles, and the same side interior angles, and just keeping our diagrams nice, neat, and clean. And then you're going to need to use a lot of equations to solve this. So let's quickly, here's a look at the practice. I'm going to say you want to do all that. I'd suggest a lot of practice with this. So again, at your own discretion, practice what you want, but I would practice a lot because trust me, as someone that's done this many times, I still trip up on these, and they're not embedded in my brain the way they could or should be. So just do as many of these as you feel is going to help you become better at this. So that's that. Let's go back and verify our essential question, because you guys we've been doing this for a while. This was a long lesson today. Essential question: how can you prove and use theorems about angles formed by transversals that intersect parallel lines? Well, an answer could be that, by when you start out and you establish that there's a postulate with certain pairs of angles, for example, same side interior angles, the postulate allows you to prove a theorem about the other pairs. So you can then pull in alternate interior, corresponding, etc. So using the postulate and theorem lets you prove other theorems and other pairs of angles, and that's the beauty in this, is that once you can figure out what you know, you can figure out everything that you don't know. So that's it, guys. Thanks for being here. Lesson 4.2, transversal parallel lines. And again, we're heading into break. November's always rough, but we're rolling. So definitely, guys, the moral of the story today is take good notes. Study these words because they're tough. And if you're not a studier, you're gonna struggle. Go eat something good. Send me, comment down below your favorite Thanksgiving dish. And try cooking. You guys are getting older. Try learning at least one dish. So that's it, guys. It's Mr. Hansen at Mr. Hansen 414. Hit that like button. Share this out. Give me some more subs. I'll see y'all later.